So now the topic is bridge method, or how does covariant return type work in Java. Now there are two things, but the concept is same. There are two names, but the concept is same. Bridge method, or how does covariant return type work in Java. So in the interview, they might ask you, explain bridge method, or what is bridge method in Java, or they might ask you, how does covariant return type work in Java. Both these have the same answer, have the same concept. Let's see what is that. Now, as you know, one of the rules of overriding, one of the rules of method overriding in Java is overriding method can have covariant return type. Overriding method can have covariant return type. So let's see with the example. Suppose we have class base, in which we have public object display. In which we have written SOP in base display, and we don't want to return any specific object, so we say return null. And then we have class sub extends base public. Now here, if I write object, this will be same return type. That is allowed. But from Java 5, there's one change in the rule, and that change is overriding method can have covariant return type, meaning it can be any subclass of object. As you know, the meaning of covariant is overridden method can have parent as a return type, and overriding can have child as a return type. That is the meaning of covariant. In sub display, again here return null. Okay, now this is perfect overriding, and somewhere in public class demo, let us write complete example. PSVM, public static void main. Now we write code in different ways. Sometimes we write base ref is equal to new sub, that is upcasting, and then ref dot display. Or we write sub s1 is equal to new sub and s1 dot display. Okay. Difference is here upcasting is done, here upcasting is not done. But from the execution point of view, or from the runtime point of view, there is no difference between these two, right? Here also subclass display will be called, and here also subclass display will be called, right? Now our discussion is not that. Our discussion is what is bridge method, or how does covariant return type work in Java. Now let's see base class and subclass. This is overridden method, which has got parent, which is the object class, as a return type. This is overriding method, which has got child string as a return type. So this is covariant return type. Now this is covariant return type. Agreed, this is covariant return type. And compiler also allows us to write covariant return type. Compiler has no problem. But JVM does not understand covariant return type. JVM does not understand covariant return type. For compiler, this is overriding. But for JVM, this is not overriding because return type is not same. I repeat, JVM does not understand covariant return type. So for JVM, this is not overriding, this is something else. So now what compiler does? Compiler understands that this is covariant return type. Compiler has allowed you to write covariant return type. That's why you have written the code and it gets compiled also successfully. But compiler does understand that JVM does not know anything about covariant return type. So now compiler has to do something. Compiler has to do something with the code. What compiler does? This is your code. This is your code. Now, when you compile this code, especially class sub, what compiler does? Compiler adds one more method here, which has got matching signature of base class method or overridden method. I repeat, compiler adds implicitly one method which has got matching signature of overridden method. What is the signature of overridden method? Public object display. And then compiler here writes an instruction to invoke public string display. Notice that compiler adds one more method in the child class implicitly, which has got matching signature of overridden method. What is the signature of overridden method? Public object display. Exactly same signature this method has got. This method is added by whom? Added by compiler implicitly. And what is the instruction in that method? The instruction is to invoke public string display, which you have defined. This is the method you have defined as a programmer, and this is the method compiler has provided implicitly. So the method which compiler provides implicitly, from that method, the actual method which you have defined, gets invoked. Okay. Now, how does it work overall? I just add this method here for our discussion here. But make sure you followed that this method you have added and this method compiler has added implicitly. Okay. Now, whether this code or this code, no difference. Whether this code or this code, no difference. What happens? Suppose here, during runtime, what is the content of ref? Sub. So sub method gets called. That is what we say, right? Here, what is the output? What is the output of this program? In sub display, right? I hope there is no doubt about this for you. In sub display, correct? But how does it work now? Ref.display. Recall what is compiler's instruction here? Check the content of ref and invoke display. Check the content of ref and invoke display. So during runtime, which display gets called? During runtime, this display gets called. During runtime, this display gets called, which invokes the display which you have defined. Okay, we always say that for other cases, we always say that ref.display, what is the content of ref? Sub. So sub means directly control goes to this method. That happens. But in other cases, in case of covariant, what will happen? When you say ref.display, this method will be called. This method will be called, and this method, which is added by compiler, invokes implicitly which method? The method which you have defined. Okay. In this case also, s1.display. S1 content is sub. So sub method will be called. But again, which actual method gets called first? The method which compiler has added. And you know that method calls your method implicitly and you get the output. Okay. So here, if we understand with the help of diagram, this is the actual method. Public string display. Public string display. This is user or caller. And this is the method implicitly added by compiler. What is that? Compiler adds one method in the child class which has got matching signature of overridden method. So that is public object and display. Okay. This is the method we have defined. This is the method compiler has added. From this method, compiler calls public string display. And we are here, caller. Now caller calls the method as per our example, either ref.display or s1.display, right? s1.display. So we are always under impression that when caller says ref.display or s1.display, this actual method gets called. No. When caller says ref.display or s1.display, whatever you write, first control goes here, number one. And then this method invokes public string display, which you have defined implicitly. This method, which is added by compiler, invokes your actual method. That is number two. So now you can see the actual method is called with the help of the method which compiler has added implicitly. I repeat, actual method gets called with the help of the method which compiler has added implicitly. So because of this or using this method, the actual method gets called. Using this method, the actual method gets called. This method is known as bridge method. This method is known as bridge method. And that's how overriding covariant return type works in Java. This is bridge method. I hope you've understood this, why this is called as bridge method. What is bridge? Bridge is the one using which we go from one side to other side, right? So it is same. This is the method with the help of which you reach the actual method. So this is called as bridge method. So in our example, the method which is added by compiler implicitly is called as bridge method. Okay. From that bridge method, actual method which we have defined gets called. And this is how covariant return type works in Java.